Okay, this is the first lesson of our next unit, which is the area of polygons. And so this up here is just a review of what we did when we did quadrilaterals. And it goes through, if we have 3 sides, it's a triangle, 4 sides, it's a quadrilateral. So we've been through all of that. You know the names of the polygons. So I'm going to move down here. This is also something we kind of already know, but we only talked about quadrilaterals, so we only named polygons with 4 sides. So if we have an octagon with 8 sides or a pentagon with 5 sides, this here is a hexagon, then we need to name it with all of its letters. So we are going to name this hexagon DHKMGB. And so I picked a letter. I went clockwise around the figure. So just like with a lot of things that we do in class, that's not the only name for it, because you can see I have an or. I could have started with that same letter and went counterclockwise and called it DBGMKH. The key is to not skip any letters and not skip around. I could have started with a completely different letter. I could have started with M and went clockwise and called it MGBDHK, or went the other direction. So there's lots and lots of names for this polygon. It also asks us to name the vertices. And again, the vertices are just the letters. It's where our 2 sides come together. And so we just list those with a comma in between, because that's different than naming it where we don't have the comma. It shows that we're separating out each vertex. Then the angles are the vertices. We just specify them as angles because eventually we're going to talk about their measures. So angle D, angle H, angle K, angle M, angle G, and angle B. And then the sides, remember, we notate that with that segment bar above the top. So I went in the same order I went in when I named the figure this way, and I said side DH, side HK, side KM, side MG, side GB, and side BD. Just another side note, we are only going to be looking at convex polygons. We're not going to get into much of a discussion about convex and concave. The polygons that we're going to be finding the area of will be convex, which means all of their diagonals will be within the polygon. I know that picture is hard for you to see. You can always enlarge it in the completed notes, but there's a quick view of it. All of that top figure, all of the diagonals are within the polygon, and in a concave figure, some of the diagonals can be outside of the polygon. So I'm going to actually skip this. I'm actually going to skip this down here because that just deals with the convex and the concave, and that's not going to be important to us. Here is one of our first formulas. It's called the polygon angle sum theorem, and it's when we take n minus 2 times 180, and that's going to equal the sum of the interior angles. So this is for interior angles, and n is the number of sides. So if we look down at this example, find the measure of the angles of a 15-gon. Well, I want the sum of the measure of the angles. So I'm going to set that equal to the formula n minus 2 times 180. N is the number of sides, so I plug in 15 for n. So then to do this, I'm going to take 15 minus 2, which is 13, times 180. So 13 times 180 is, so the sum of my angles is 2,340. And so that's my answer there. So in a 15-gon, if we added up all the angles, it's 2,340. Think about that like if we had a triangle and we added up all the angles, it equals 180 degrees. It's the same way if we had a 15-gon. If we added up all the angles, it doesn't equal 180. It equals 2,340. So let's look at that again. The sum of the measures of the polygon is 720 degrees. How can you use the polygon angle sum theorem to find the number of sides of the polygon? So we're given a little bit different information here. Now we have that the sum is 720. So if I use the same formula, 720 is the sum. So I'm going to put that 720 in for sum. And then I have equals n minus 2 times 180. So I want to solve for the number of sides. How can you use the formula to find the number of sides? I want to solve for n. So 180 is being multiplied on this side, so I want to divide by 180. So if I take 720 and divided by 180, I get 4. 4 equals n minus 2, because that cancels, so we're left with n minus 2. So I'm going to add 2 on both sides, and n will equal 6. So how can you use the formula to find the number of sides? We have 6 sides. Sometimes it asks you, and then what is the figure? This one didn't, but it's a hexagon. So 6 sides was what we were looking for here. There's another way we can use this formula. It's when we have a figure and I'm missing an angle. I have an x here. What is that angle? I know this one is 90. I know this one is 90. So eventually I'm going to do 90 plus 90 plus x plus 90 plus 135 equals this plus this plus this plus this plus this equals, but I don't know what it equals yet. I have to figure out what it equals by using this formula first. So sum equals number of sides, 1, 2, 3, 4, 5. 5 minus 2 times 180. 5 minus 2 is 3. So 3 times 180 equals 540. So sum equals 540. So I know that 540 goes right here because plus 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 is sum. I just found the sum, so I'm going to put that right here. So now I can actually do 90 plus 90 plus 90 plus 135. 90 plus 90 plus 90 plus 135 equals 405. So I have 405 plus x equals 540. That's still the sum. If I subtract 405 on both sides, x equals, let me do that again, 540 minus 405. I think I hit another button. Nope, 135. 135 degrees is what that angle equals. So then we have one other formula that says the sum of the measures of the exterior angles of a polygon, one at each vertex, is 360 degrees. It doesn't matter how many exterior angles we have. Look at how we extended all those sides, and now we have an exterior angle here, 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 and here, and here. And when those go around, they form a circle, so they're 360. I could take the smallest polygon that I have, that's not a great drawing, and give it exterior angles. Yikes, there we go. I'm going to give this one exterior angles and call them 1, 2, and 3, and they go around in a circle. They would equal 360 degrees. So the more exterior angles we have, the smaller number that we'll get. So these angles are going to be a smaller measure than these angles, but they will all equal 360 when we add them up. So the sum of the exterior angles equals 360. So something important about that is we need to remember that an equilateral polygon has all sides that are congruent. An equiangular polygon has all angles that are congruent. And a regular polygon has angles and sides that are congruent. So that's when we think of like a square. All the sides are congruent, all the angles are congruent. That's a regular polygon. And we are going to be looking at some regular polygons possibly later in the unit if I don't think those lessons aren't too hard. So for a regular, regular right here, regular sided figure, find the following, each of the following. The measure of an exterior angle. Well, if all the exterior angles equal 360 degrees, and there's going to be 8 sides, it means there are 8 angles. Because look at here, if I go back up to this one, There's 1, 2, 3, 4, 5 sides. So there's 1, 2, 3, 4, 5 exterior angles. So if they're all the same measure and I just want to find one of them, I divide by 8. So the measure of one exterior angle, 360 divided by 8, is 45 degrees. So that's my answer for that. The measure of one interior angle. Because it's interior, I have to use sum equals n minus 2 times 180. Because this is interior, this is exterior. So sum equals, I know I have 8 sides, so 8 minus 2 times 180. So sum equals 6 times 180. 6 times 180. All right, my sum is 1080, but that's the sum of all the angles. But if I only want one angle and they're all supposed to be the same, I want to take that 1080 and divide by 8 to find just one of them. So the sum of one of those angles when I divide by 8 is 135 degrees. And then this one's a little bit difficult, so we're going to skip that one. And we're going to move to the homework, and I'm going to do one of each type of problem. So I want to do number 1. So we are finding an interior and an exterior angle. An exterior angle is pretty easy to find. So if all the exterior angles are supposed to be the same, like I could draw them all on here. I could draw one right here, and I could draw one right here. And they all go in a circle. There are 3 of them. So I would take, for an exterior angle, I take 360, I divide by 3. So x equals 360 divided by 3, 120 degrees. So that's x. For an interior angle, for an interior angle, I want to take sum equals n minus 2 times 180. So sum equals 3, because n is the number of sides, so 3 minus 2 times 180. So sum, 3 minus 2 is 1 times 180. So the sum is 180. 1 times 180 is 180. But that's, remember, the sum of all the angles. If I want just one angle, I'm going to divide by 3 because there are 3 of them here. Y, Y, and Y, there are 3 of them, so I'm dividing by 3. And one exterior angle, 180, divided by 3 is 60. So in number 2, you are only finding the exterior angle. So 360 divided by the number of sides, because that will also equal the number of angles. In number 3, you're finding an exterior angle, so you need to do this, and an interior angle, where you're using the sum equals the number of sides minus 2 times 180. That's going to get you the sum. Then, after you find that, you divide by the number of sides to get you just that one angle. That's the work that I did over here. Then, so when you're done, you're going to end up doing 5 problems. These 2 and 3 of them down here. So let's look at number 5 together. And what I do in number 5 is what you're going to do with these 3. So we have all these angle measures. This is like, this is like what we did right here in the notes. So I'm going to first start, these are all interior angles. They're inside the polygon. So these are interior. So I need to use sum equals n minus 2 times 180. So I want the sum, the number of sides, 1, 2, 3, 4, 5, 6. So 6 minus 2 times 180. 6 minus 2, I don't know why I'm using the calculator, because 6 minus 2 is 4 times 180. So now we want to do 4 times 180.